Discussion of exercise rate of the reaction. As we discussed the first question and the second question, first part, which was how the rate of a reaction changes. So we'll say the rate of this reaction decreases, and why it decreases? Because the amount of the reactant decrease or the number of the particle decreases. And as the number of the particle decrease, less collisions in a unit time. And eventually what will happen? The limiting factor or a limiting reagent used up. The next one is the experiment was repeated using same mass of a powdered magnesium carbonate. As you can see in the beginning, but we use the same volume and concentration of a hydrochloric acid. So what we did, the first reaction, we used the large pieces of the magnesium carbonate, but the next reaction, what we did, we used the powdered magnesium carbonate. So what happened to the rate of the reaction and what happened to the amount of the product? So first, what happened to the rate or the speed of the reaction? Will it increase, decrease, or remain same?
Increases.
So rate of the reaction,
Increases.
we'll say the rate of this reaction will increase. And why the rate of the reaction will increase? Because powdered
Has a larger surface area.
Yeah, powdered magnesium carbonate has large surface area. So the powdered will have a large surface area. That's why the rate or the speed of a reaction increases. But what happened to the total volume? In the question, they said that we are using the same volume, same mass, same concentration. So we are not changing the amount. We are only changing the surface area. So if we change the surface area, the rate of the reaction will change. But what happened to the total volume? It will be same. And why it will be same? Because there is no change in amount of the reactant. Because if we change the amount of the reactant or the limiting factor, then the rate, the amount of a product will also change. So the total volume of the gas, what we collected, like example, first let's say we collected 60 cm cube of a gas. So when we use a large, like a powdered magnesium carbonate, it will have a large surface area. So the initial reaction rate will be faster, but eventually it will give the same amount of a product because we are not changing the amount of the reactant. We are using the same amount of reactant. That's why we'll get the same amount of product. Is it clear? Part 2. Anyone having a doubt?
Yes, sir.
Okay. The next is a piece of a magnesium ribbon was cleaned. The experiment was repeated using. So what was the reason? The previous question? Yes, I'll repeat. For the previous question, we use a powdered reactant, but we use the same mass, same concentration, same volume, but only difference was a powdered reaction. So if we were having a powdered reaction, what will be the effect of the powdered reactant? The powdered reactant will have a large surface area as compared to large pieces of the reactant. So large surface area, the reaction will be fast or the rate will increase. But what happened to the total volume? The total volume will be same. Why the total volume is same? As we are using the same mass of the reactant, same volume and the concentration of the reactant, that's why the total volume won't change. Because the total volume depends on amount of the reactant. And the rate of the reaction changes because you are using a large surface area of the powdered reactant. A piece of a magnesium ribbon was cleaned. An experiment was repeated using a magnesium ribbon instead of magnesium carbonate. So magnesium reacts with hydrochloric acid to give a hydrogen gas. The reaction is exothermic. The rate of this reaction gradually increases over the first 2 minutes. Explain why the rate of a reaction increases. So what is the reason if a reaction is exothermic, why the reaction gets faster in the first 2 minutes? So the reaction is exothermic. So the temperature of the mixture will increase. As the temperature increases, what is the effect of the temperature? So it will increase the kinetic energy or
No
speed.
collision.
Yes. So when we have
Nothing,
an
sir.
exothermic reaction, yes, Abdullah.
Nothing.
So when we have an exothermic reaction, the temperature of the mixture will increase. What is the effect of this increase in temperature? It will increase the kinetic energy or the speed of the particles. Or we can say there will be more collisions in unit time. Like more particles will collide every second, and there will be a greater number of the particles with energy more than activation. And eventually what will happen, like greater number of particle of with energy more than activation energy, then the so speed of the kinetic energy increases. We can also say more collisions in unit time. And greater number of the particles with energy more than activation energy. So the rate will increase. That's how you write the structure whenever anything is related to temperature. Whenever anything is related to temperature, you will always list these points, okay?
Sir, I have a question.
Yes.
Sir, it says the reaction is exothermic.
Yeah.
Shouldn't the temperature decrease because it
Look, what will
emits,
happen
I
if
mean,
the
it
reaction
produces
is
heat?
exothermic? The exothermic reaction releases energy. So let's say these dots are representing the reactant particle. When these reactant particle combine, the release energy. When they release energy, this energy is taken by the solution in which they are present. So if a reaction is exothermic at the beginning of experiment, if the temperature was 18, after the experiment, the temperature might be 25. So the temperature of the mixture, because the energy which they are releasing, that is causing the increase in temperature of the mixture. That is not like going out to the surrounding, that energy which is released. It's not going out like this. It's first absorbed by the mixture. That's why the temperature of the mixture is increasing. So in exothermic reaction, the
Yes, sir.
temperature of the mixture increases. If it was an endothermic reaction, the temperature of the mixture will decrease. Is it
Sure.
clear?
Thank you, sir.
Is it clear?
Yes, sir.
Sir, can you repeat this question?
Look, in this question, what is happening? A magnesium is reacting with a hydrochloric acid. So magnesium is a solid. Let's say this dot is representing a magnesium, and hydrochloric acid is an aqueous. Aqueous means it is mixed, dissolved in water. So when a magnesium combined with a hydrochloric acid, the reaction is exothermic. Exothermic reaction means it releases energy. So when it releases, the combination or a mixture releases energy, that energy is not directly going to the surrounding first. It is absorbed by the surrounding particles. When the surrounding particle absorb that energy, so what happened to the temperature of the mixture? The temperature of the mixture will rise. If the temperature of the mixture will increase, so now the particles will have more energy, more kinetic energy or higher speed, or they will collide more often, and more particles will have energy more than activation. So the rate or the speed of this reaction will increase.
Okay, sir. Thank you.
Is it clear?
Yes, sir.
Okay. Yeah, the product is having less energy in exothermic, so remaining energy is going to the surrounding, and that surrounding is a mixture. So another question related to the rate or the speed of a chemical reaction. a student investigated the progress of a reaction between a hydrochloric acid and excess of a large pieces of the marble calcium carbonate. So here, hydrochloric acid mixed with calcium carbonate, it will give a carbon dioxide gas, and we're collecting the carbon dioxide gas. A graph of a volume of a gas produced against a time is shown. Like we collect the volume of the gas and that graph is shown. How does the shape of a graph show that the rate of a reaction decreases as a reaction progress? How I can say that the rate of the reaction is decreasing from the looking at the graph? The rate is decreasing, but looking at the graph, or how you can say the rate is decreasing? So what is the
The slope is
The
decreasing.
slope is decreasing, or
So you will say this because the rate of the reaction is the slope of this volume time graph. So we'll say the slope is decreasing. As the slope is decreasing, because the slope represents the rate, so the rate of this reaction is also decreasing. For a volume time graph, the slope represents the rate or the change in the amount over time, that is also representing a rate. Why did the rate of the reaction decreases? Why the reaction rate is decreasing? What could be the reason?
sir, because the reactant decreases
Good. So the amount of the reactant decreases
and
because in
amount of collision decreases as well.
what's the second point you said?
Amount of collisions decrease as well,
Yeah, good.
and
Amount of
limited
reactant
reactant decrease,
decrease, or you can say
limited
less
reactant
collisions.
used up.
No, they
Sir, I had
did
a
not
question.
ask. If they ask us why the reaction stopped, then we'll say the limiting reactant used up. But they did not ask us why the reaction stopped. They asked why the rate of a reaction decreases. Like why the reaction is getting slower. So why the reaction is getting slower? Because in the beginning you will have more particles of the reactant. But as the reaction progresses, the amount of the reactant particle decreases. That's why the rate or the speed of the reaction decreases.
Oh, sir, I had another question.
If they ask us like why the reaction stop, in that case you will say the limiting factor or the limiting reagent used up. Is it clear?
Sir, I had a question.
Yes, sure.
What if the same question is of 3 or 4 marks? Then what would be the
Then
answer?
yeah, same question of the 3 or 4 mark like we did in question 2. If you see this part, this was 4 mark, and they said describe how the rate of a reaction changes during this reaction. So we have to explain this whole graph. So how we'll explain? First thing we'll mention the rate of a reaction decreases because amount of the reactant decreases, number of collisions in a unit time decreases, and eventually the reaction stop because the limiting factor used up.
Okay.
That's a 4 mark answer. But here it's of only 1 mark, and they just ask us why the reaction is decreasing. So we'll say because the amount of the reactant is decreasing or the number of the collision unit time decreases. That's it.
Clear.
After how many seconds did the reaction finish? Can anyone identify when this reaction stopped?
120.
Good.
120, sir.
It was constant after
120, because
120.
you can see when it is 120, the amount does not change. So it means when we reach 120, the reaction has stopped completely. So after how many seconds the reaction has stopped? So
120.
120 seconds, the reaction has stopped. The next part, experiment was repeated using a same mass. Draw a graph reaction with the smaller pieces of the marble. If I use smaller pieces of the marble, it means they will have large surface area or small surface area. If I use
Large
Large
smaller,
surface area, sir.
Large, more particles exposed.
So the
yeah, so I will have
so the
large,
rate will
they will
be
have large
slower.
surface area. But we
So the
did not
slope will
change.
be more steep.
Yeah,
Slope will
good.
be more steep.
That's right. It will be steeper, but the final product will be same. Why the final product is same? As I mentioned, we are using the same mass of the marble chips. So if we are
Yes, but the
using this,
reaction would be faster, but it would be the same.
the reaction will be faster, but it will eventually give the same amount. So how to draw such? I will roughly you have to sketch. It's not like any by any calculation. So you have to sketch. The reaction should be faster, but the final product should be same.
So how fast, sir?
Because we are using Small pieces of the marble. Small pieces of the marble means large surface area. Large surface area.
Oh, okay.
So the rate of the reaction should be higher or faster. Why the surface area is increasing? Because they already specify we are using the same amount of the marble, but what we did, small pieces of the marble. When I have a small pieces but the same amount, so overall surface area, when I like if I take this one piece and I crush into small pieces, which will have a large surface area. So the small particle size will have the large surface area. This will have a large surface area or react at a higher rate or much faster. Is it clear?
Yes, sir.
Okay.
Yes, sir.
The next is a 5-mark question in which they mention the original experiment was repeated at a higher temperature. See, if I give you an idea, look, sometime higher temperature, how many mark question was there? 5. Sometime the same question when we do the experiment at a higher temperature. Here also 5. Here how many marks? The experiment repeated high temperature 3. But the structure of the answer does not change. Whenever you write the structure of the answer, it should be same, even it's of 3 marks, 4 marks, or 5 marks. That if we do the experiment at a higher temperature, explain in terms of the collision effect of high temperature on a time for a reaction to finish. So first, when we increase the temperature, and I will tell the marking scheme answer as well, like the mark distribution. Increase in temperature will increase the kinetic energy or speed of the particles. So more collisions in unit time, more or greater number of the particles have energy more than activation. So the rate will increase or reaction complete in or finish in short time. Because if the rate of the reaction is higher or faster, the reaction completed in a short time. So how the marks are distributed for this question or distribution of the marks for this? So 1 mark for I'm just using for writing time will be short. So you will score 1 mark for that. 1 mark for particle will have more energy. Like increase in kinetic energy, that will 1 mark. 1 mark for speed as well. Like particles move faster. So sometime increasing kinetic energy and speed is only 1 mark. Some cases the marks will be 2. So you always try to refer. Then more collisions in a unit time. 1 mark for this, more collision in a unit time, 1 mark. And greater number of the particle will have energy more than activation, that is 1 mark. So that's how you score all the 5 marks. So same answer, I did not change the answer, even the same I wrote for the 4 marks, but you will see that sometime the kinetic energy speed have separate marks. Some questions they give you the same mark for the, like even writing kinetic energy speed, that will be 1 mark. So try to learn the structure of the answer related to a temperature. So it is very important. Every year, almost every past paper, you will find a question in which we change the temperature and how the rate of the reaction changes. Sometimes if they say the experiment temperature is lower, so what we'll just change, we'll say decrease, decrease, less, few, decreases, and long time. The only things we'll change this. Rest all of them will remain unchanged. Is
I
it?
have a question.
Yes.
So the sentences should be grammatically correct.
Yes,
Oh.
sentence.
I can just write them in like,
spelling
bullet
mistakes,
points.
not look. Some they do ignore the spelling mistake, so you will not lose the mark for the spelling mistake. But some question structure, the grammatical structure should also be correct. But there's no deduction for the mark if your structure of the answer not grammatically correct. They don't deduct the mark, but you are writing answer in English, so at least it should be grammatically correct answer. Is it clear? So you will not lose the mark for the spelling mistake or the grammatical mistakes.
Yes.
What is the effect of increasing a surface area when we have a large surface area? So large surface area, when we have a powder or a powdered form is there, like here we are using lumps. But if I use a powdered form, the same amount, let's say this was 2 grams of lumps. If I use 2 grams of the powder, so 2 grams of the powder will have a large surface area. When it has a large surface area, it will consume or react completely in a short time. So large surface area, more collision in a unit time, so the reaction will be faster. But it's not like it does not affect the amount of the product, because the amount of the product depends on amount of reactant and specifically the limiting factor. The next question. A student investigates the rate of a reaction between the lumps. As you can see, these are the lumps of calcium carbonate. So these are from different past papers or past exam papers, but you see the same type of a question. Lumps reacting with a hydrochloric acid. Here also lumps reacting with like large pieces of a marble reacting with a hydrochloric acid. Large piece of a magnesium carbonate reacting with a hydrochloric acid. So, and sometimes this thiosulfate and a hydrochloric acid, that the time taken by a cross to disappear, sometimes they do give this question. But most of the time is about acid reacting with marble chips and giving any gas. And we are collecting the gas, the volume of the gas. Question 4. A student investigates the rate of the reaction. So a student is investigating the rate of a reaction between the lumps of calcium carbonate and the dilute hydrochloric acid using the apparatus shown. The calcium carbonate react with the hydrochloric acid to give calcium chloride plus carbon dioxide plus water. So when calcium carbonate react with carbon dioxide, hydrochloric acid, a carbon dioxide gas is given off, and we collect the gas which is given off here. The calcium carbonate is in excess, like it is more than enough, so it will not be used up, or when the reaction end or finish, you can still see the calcium carbonate. Which measurement should the student make during the reaction to determine the rate of the reaction? What student should measure in this reaction? Which 2 quantities he should measure to get the rate of the reaction?
Carbon dioxide.
Good, carbon dioxide, but what carbon dioxide? Mass, volume, what I should measure?
Surface area.
What I should
No, sorry.
measure?
Volume.
So the volume of a carbon dioxide or a volume of a gas, that's one thing. What is another thing I should measure?
Surface area.
No. I need a rate. How I can get the rate? Yes, what else?
The volume of the
Time,
dilute
time.
hydrochloric acid.
Mass of the mixture.
Time.
No, mass of the mixture in that case, if we allow the gas to escape, in that case, we'll measure the mass of the mixture. Yes, Abdur Rahman, that's right. Hadi, you're also correct. So we should, because we want to measure the rate. Rate is something with reference to time. So without measuring a time, if I only measure the volume of the gas, I won't be able to determine the rate of the reaction. So if I need the rate, if I need the rate of this reaction, so to get the rate of the reaction, it will be the change in the volume of the carbon dioxide or the volume of a gas divided by time. So which quantity I should measure? The volume of the gas or a carbon dioxide and the time it takes, because I cannot determine the rate without time. So one is the time, another one is the volume of the gas. How I can measure the volume of the gas? Which apparatus?
By the gas range.
So I will use a gas syringe. So gas syringe will be there. How I'll get the time?
Through stopwatch.
Watch.
So we'll use a
Clock.
stopwatch. Yeah, we'll use a stopwatch or a watch to measure the time. So we'll mention stopwatch or a stop clock. What happened to the rate of a reaction as a reaction proceed? Explain your answer. This is the same question, like you have to explain the whole. What happened to the rate of a reaction as a reaction goes on? Rate of a
Decreases.
reaction, remember my word, rate of a reaction
Increase.
does not increase. It will always decrease. So first thing what we'll say the rate of the reaction will
Decrease.
decrease. And why the rate of a reaction will decrease?
Because the reactant
Because the reactant is used
is
up.
decreasing.
Yeah, the amount of the reactant is decreasing or the collision will decrease, and eventually what will happen?
The,
Reaction is not.
limited reactant would be used up
Yes,
entirely.
that's a very important thing. You have to use the term limiting. If you only say reactant used up, the reactant is a calcium carbonate and both hydrochloric acid are the reactant. So one of them will be used up and that will be the limiting factor. They already mentioned calcium carbonate is excess or more than enough. So we'll say the limiting factor or limiting reagent or hydrochloric acid used up. So how you structure this answer, you will say the rate of the reaction will decrease. Why the rate of a reaction will decrease? Because the amount of the reactant decrease which reduce the number of collisions in unit time. And then what will happen? The reaction stopped because the limiting factor or a limiting reagent used up. So rate of a reaction decrease as the reactant is used, and eventually what will happen? The react. So when you say that amount of a reactant is decreasing, you should always relate with the number of the collision. So this statement is important. So the amount of the reactant decreases with will reduce the number of the collision in unit time. Here I just wrote unit, but it should be unit time. And then eventually what will happen? The reaction stops because the limiting factor used up. So I can also say the name of the chemical because it's a hydrochloric acid is a limiting factor or a limiting reagent. So I can say that the hydrochloric acid is used up.
So what does limiting factor mean?
Yes. Yes.
What does limiting reagent mean?
Limiting reagent means when a chemical reaction happen or occur. If I say, like example, A is reacting with B and forming C, and I'm using 2 grams of the A and I'm using 5 grams of the B. So I need the same amount of A and B, but I'm using more than enough. So when the reaction end, what will happen? There will be 0 grams of A and there will be still 3 grams of the B will be left behind. So this 3 gram of the B, it means that is an excess and A is a limiting reagent. So the
Yeah.
one.
So won't it only be limiting if the reaction is affected on the mass? Like if is that less and the reaction can't happen, then and only then would it be limiting, right?
Sorry, Hadi, can you repeat your question and a bit louder because my audio device is not working properly. Can you just repeat your
So you're
question?
saying that A has 3 grams and after the reaction it is 0 grams, then
Right.
it is a limiting factor. But if
Right.
it's all used up and the reaction is still going, then it won't be a limiting factor because the reaction happened perfectly.
No, but for a reaction to happen or occur, I need both of the reactant. So because A is combining with B to get C or producing C. But what happened if A is completely used up and B is still left behind? So the reaction will stop because the reaction need both A and B to complete. Clear?
Yes. Yes.
So limiting factor or a limiting reagent is a reactant which once it used up or it is no more there, the reaction will stop. So what will happen? In this question, as I mentioned, a calcium carbonate is in excess. So when it is in excess, so once hydrochloric acid is used up, the reaction will stop. What happens if a surface area or a volume is changed? If we change the surface area at a higher temperature, the rate will also increase. And if you use a large amount, definitely it will also increase. The next is, again, if you see the same question, a student repeated the experiment at a higher temperature. So he's using a high temperature. Other conditions are kept same. Explain in terms of collision why the rate of a reaction increase. So high temperature, what will the structure answer? As I mentioned, high temperature means
The
Kinetic
molecules
energy
move
speed
faster and
increases.
collide faster and make
Yeah.
more energy.
So high temperature
Okay.
means kinetic energy speed will be higher. What is the result of that? There will be more collisions in a unit time. And there will be more particles.
Faster collisions with
Greater
more
number of
energy.
particles
Faster collision plus
having energy.
more particles with energy more than activation. Like greater proportion or number of the particles have energy more than activation. So eventually the rate will increase. Apart from using a high temperature, suggest two other method increasing a rate. How I can increase the rate other than temperature?
Surface area, volume, concentration, or catalyst.
Yeah, good. I can change the concentration. I can use a catalyst. I can increase the surface area. I can use a catalyst. I can use high concentration of the reactant. Any two we have to write here. Yes, concentration you can also write. This is the same question. As you can see, organic solution is there and there's a nitrogen gas is given off. Rate of this reaction can be measured using the following apparatus. A volume in a time. How does the rate of this reaction vary with time? What happened to rate of reaction? Does it increase, decrease, or remain
Decrease.
same?
Increased.
So rate of reaction, because the slope is
Decreases.
decreasing, so the rate of the reaction will decrease. So even in exam, if you write the term decrease, you will score the mark. Okay? Or you can say the reaction stop after some time. The rate of a reaction is decreasing and eventually it will stop. Because how we know it is stopped, as you can see, this part looks a horizontal. It's not exactly, but looks horizontal. So it means the reaction stop here. Why does the rate vary? Like why the rate is changing? What is the reason for that?
The reactant decreases, the
The amount
collision
of reactant
decrease.
decrease, so number of the collision will
Decrease.
decrease. So the amount of the reactant decrease or less collisions in unit time or fewer collisions in a unit time. The next is the reaction is catalyzed by a copper powder. Like we use a copper as a catalyst. We have to sketch a graph for a catalyzed reaction. If I draw a catalyzed reaction, if I draw a graph like this, is it correct?
No.
No, sir.
No.
It's wrong
The
because the
slope should
reaction
be
should be
steeper.
faster. If I draw like this,
Yeah.
is it correct?
Yes.
Yes, sir. It's correct.
Is it correct?
Yes, sir.
Sure. Is it correct?
Yes, sir.
Sir,
Yes,
can
sir.
you repeat?
My question is, if I'm
Volume.
using, yeah, but the thing is, this is right in terms of steeper, but I should not get a higher amount of the product. What I should get the same amount of a product in a short time. So the final amount should be same.
Wasn't both the same, sir?
So the final amount should be same. That is how I should sketch. So why you will score, how you'll score the 2 marks? My question was the reaction was catalyzed by a copper powder. If you use a catalyst, the reaction will be faster. The rate or the speed of the reaction will be higher or the reaction will be faster. but the final product will be same because the catalyst does not alter the amount of the product, so final should be same. So 1 mark is for drawing the steeper and 1 mark is for drawing the final product to be same. Why is a copper powder more effective than a single piece of a copper? Even when we are using a catalyst, if I use a large piece of the catalyst, like example, if I'm using a piece of the copper,
Surface
More
area.
surface area.
and I use a powdered copper, which will be more effective?
Powder copper.
The powdered
Powder
copper will
copper.
be more effective, and why it will be more effective? Because it will have a large
Large
surface
surface area.
area. So why is the powder more effective? The powder is more effective because it will have a large surface area.
Surface area.
Is it clear?
Yes, sir.
So different questions from the same exercise, a variety of the questions are there related to the rate or the speed of a chemical reaction.